We have seen a simple DC electrical system using one generator and one busbar. Larger aeroplanes with more than one engine will normally have a generator or alternator driven from each engine, and a more complex distribution system. In this lesson, we will examine a typical DC power distribution system on a twin-engine aircraft. It is important that the distribution system is designed in such a way that faults in the system or generator failures produce the minimum amount of disruption. Power source failures are protected against by ensuring that each generator or alternator has sufficient capacity to carry the extra load in the event of a single generator or alternator failure. In order to ensure the continuity of supply, generators or alternators can be operated in parallel. Or switching systems can be incorporated to ensure that the loads of a failed generator or alternator are taken by a serviceable unit. Failed generators can be isolated from the distribution system. In order to protect the system from busbar faults, systems have more than one busbar, any of which can be isolated from the supply in the event of a fault, while still allowing the services powered from the other busbars to operate normally. In order to decide which services are fed from which busbar, it is usual to categorize all consumer services or loads by their importance. Services are usually split into three groups, known as vital, essential, and non-essential services. Vital services are those which would be required after an emergency landing. For instance, emergency lighting and the electrical operation of fire extinguishers. These services are connected directly to the battery. Essential services are those required to ensure that the aircraft can continue to fly safely in an emergency situation. These services are connected to busbars in such a way that they can always be supplied from a generator or alternator, or from the aircraft battery. However, these services can be disconnected from the battery by operation of the battery switch. Non-essential services are those which can be isolated in an in-flight emergency for load-shedding purposes. Load shedding is expanded upon later in this lesson. Non-essential services are normally only supplied by a generator or alternator. We will now look, in a very simplified form, at a two-generator system which uses the principle of dividing categorized consumer services between individual busbars. In this example, the power distribution system is one in which the power supplies are 28 volts DC from engine-driven generators operating in parallel and 24 volts DC from batteries. The battery busbar, which may be referred to as a hot bus or hot battery bus, is always connected to the battery. The vital consumers are supplied from the battery busbar. Each generator has its own busbar to which are connected the non-essential DC consumer services. Both busbars are in turn connected to a single busbar which supplies power to the essential DC services. Thus, with both generators operating, all consumers requiring DC power are supplied. The essential services busbar is also connected to the battery busbar, so ensuring that the batteries are maintained in the charged condition. Services requiring alternating current are supplied from inverters, connected to the appropriate busbars. Essential AC consumers are supplied by the essential inverter, and so it is supplied with DC from the DC Essential Services busbar. Numbers 1 and 2 inverters, powered by DC from the numbers 1 and 2 DC busbars, supply the non-essential AC services. In the event that one generator should fail, it is automatically isolated from its respective busbar, and all busbar loads are then taken over by the operating generator. Should both generators fail, however, non-essential consumers can no longer be supplied, and the connections between numbers 1 and 2 busbars and the center busbar will be broken. The batteries will automatically supply power to the essential services and keep them operating for a predetermined period of time, calculated on the basis of consumer load requirements and battery state of charge. This must be for a minimum of 30 minutes for aircraft certified to EASA CS23 and 60 minutes for aircraft certified to EASA CS25. On the ground, an external 28-volt DC supply can be connected to the center busbar. From here, it can be used to power the entire system. In a multiple generator system, after a generator failure, the other generator is able to take the entire load initially. However, some non-essential loads may need to be switched off to reduce the load on the remaining generator. This is known as load shedding. In some aircraft, it can be automatically achieved. In others, the pilot must monitor and adjust the electrical load by use of the ammeters or load meters. That is the end of the lesson. Here is a summary of the main points that you should take from it. Power source failures are protected against by ensuring that each generator or alternator has sufficient capacity to carry the extra load in the event of a single generator or alternator failure. In order to protect the system from busbar faults, systems have more than one busbar, any of which can be isolated from the supply in the event of a fault, while still allowing the services powered from the other busbars to operate normally. Consumer services are categorized in accordance with their importance. The categories usually used are vital, essential, and non-essential. Vital services are connected directly to the battery by the hot battery busbar. Essential services can be supplied by the battery or a generator or alternator. In the event of a generator or alternator failure, the other unit must be able to take the entire load. The battery must be able to supply the vital and essential loads for a minimum of 30 minutes for aircraft certified to EASA CS23 and 60 minutes for aircraft certified to EASA CS25. Load shedding is a term used to describe the switching off of certain electrical loads to prevent overloading a generator or alternator.